Good morning, everyone, and welcome to today's webinar. My name is Martin Damon, and I'm the lead technical specialist at TruckScience. We're hosting this webinar in conjunction with NTEA, and I extend a special welcome to all members joining us this morning. We partnered with NTEA in 2019, and this partnership gives members access to our axle weight calculator at reduced rates. This webinar will cover the advantages and disadvantages of adding pusher and tag axles. I will demonstrate how adding axles increases the carrying capacity of a vehicle whilst complying with the US federal bridge laws. We will also validate our final build against state regulations to highlight how the weight limits differ between federal and state laws. And I will show you some of the unique requirements that apply to the Canadian provinces when adding axles. To demonstrate the process of modifying a vehicle, I'll take you through a live demo using our axle weight calculator. We'll start with a 6x4 chassis and a 16-foot dump body to determine our baseline carrying capacity. Next, we'll add a pusher axle and compare the new carrying capacity to our baseline vehicle. In step 3, I will increase the wheelbase by 3 feet to show you how axle spacing affects the overall bridge limit and turning radius. And finally, we'll add a second pusher and a longer body to optimize our dump truck. Jens, are there any questions before I switch to the live demo?
There are no questions at the moment, but please feel free to use the Q&A button that should be at the bottom of your screen to ask anything during the course of the webinar.
Okay, thank you, Jens. Okay, I'll switch to the live demo now. Okay, we'll start by selecting one of these manufacturers for our dump truck example. I will choose a Volvo VHD 6x4, and I'll select the one with the set forward axle and 224-inch wheelbase. This vehicle is already pre-configured with some default dimensions, chassis weights, and axle ratings. But you should always check these values and match them to the proposal document from your chassis supplier. For example, we can start off by changing the wheelbase here. I'll increase the wheelbase, or you can deselect the override to return to the default value. Over here, we can also change the bogie spread and afterframe if necessary. This chassis weighs just over 16,000 pounds. If you need to make a change to the weights, you can click on either the front or rear axle to open the vehicle menu to that particular axle. Here we can change the chassis weight if needs be, and also the gross axle weight rating. If you're not sure about an input, you can click on the information icon. This one will explain that the gross axle weight rating is the lesser of the manufacturer's axle, suspension, and tire ratings. Our bridge limit for the front axle will be 20,000 pounds, according to the US federal bridge laws, and the permissible maximum for the front axle will be the lesser of the manufacturer rating and the bridge limit, therefore 14,600 pounds. Now, it's easy to forget about the tire spec, but I would recommend that you check the tires, especially the tire width, because this can affect the regulation maximum in certain cases, especially for pusher and tag axles, where we normally run with single tire fitment. We can make the same changes for the rear axles, and under total, I will adjust or increase the gross vehicle weight rating to 67,600, which the manufacturer has approved for this vehicle. The permissible maximum will still be the bridge limit of 51,500 pounds. Right, once we've set up the vehicle, we are ready to add the body and equipment. But before we do that, I want to show you or give you a quick overview of the dashboard. Here, your calculations will be validated against manufacturer limits, regulatory compliance, and organization standards. You can even add your own favorite measurements here. If I drill down on regulatory compliance, you will see that we are validating this calculation against the federal regulations. We can now add our body, and I will choose a dump body. Here we can use a template to add a fully customizable body from scratch, or we can go to the public and distributor library to pick a body from an existing manufacturer. So if you are a bodybuilder or equipment manufacturer and you have dealers or upfitters for your products, then you have the option of setting up your own unique distributor library and approving who has access to your products. For today's example, I've already used the DXF import feature to add a 16-foot Crysteel dump body to my personal library. So I will add that to the chassis now and move it back slightly to create a clearance of 4 inches to the back of the cab. We still need to add our hoist. For this, I'll go to Equipment and choose a hoist that I've also saved to my personal library using the template feature. And I'll just move that hoist into position. And once we've added a body, the software will automatically calculate the maximum permissible payload, which in this case is 23,000 pounds. If we go down to the weights table, you will also see the payload here. And you'll notice that the front axle is the limiting factor. So our front axle has reached a utilization of 100%, which makes it the limiting factor. We still have a little bit of unused capacity on the rear axle and also on total. If you prefer, you can specify your own payload here by overriding the payload and changing that to, let's say, 24,000 pounds, which will immediately highlight the front axle to indicate an overload and also add a red cross next to manufacturer limits on the dashboard. So at this point, we are exceeding the gross axle weight rating of 14,600. Since we still have a little bit of unused capacity on the rear, we could try to shift some of this weight backwards. So I'll do that by moving the body to the rear. So in this position, as I move the body, you'll notice that the axles are all within limits. If I move the body further, we will eventually overload the rear axle. This time we'll get a red cross next to regulatory compliance, and that is because we are exceeding the bridge limit of 34,000 pounds for the bridge for the rear tandem. Okay, so now we can, if this doesn't work for you, you can always undo the change to move the body forward again and deselect the override to allow the software to calculate the maximum payload for you. All right. We'll have another look at the utilization on the rear, and we could tweak this calculation to squeeze a little bit more payload out of it. But since we are already utilizing the overall bridge limit to 90%, there's not much room to get more payload out of this axle layout. So we've pretty much reached the maximum, although we are nowhere near the maximum in terms of the gross vehicle weight rating. Now over here, we can't see the percentage utilization of the gross vehicle weight rating, but we can add this measurement to the dashboard as one of our favorite measurements so that we can observe that value as we make further modifications to this vehicle. So for this, I will go to the dashboard settings and scroll down the list of favorite measurements that are available. I might just include CDL required. This is a new attribute or new value we added recently. And scroll down to, and then add utilization as percentage of gross vehicle weight rating. That'll update the dashboard to show us that that the driver will require a commercial driver's license for this vehicle, and that we are only utilizing roughly 70% of that gross vehicle weight rating of 67,600. Okay, so this is a good indication that we can still add axles to this vehicle to increase the overall carrying capacity. Now, there are a few things to consider when adding axles. For today's example, we will focus mainly on the benefits to the overall carrying capacity, but we will also take into consideration chassis space and the effect on turning radius. So to add an axle, we can go to the vehicle menu and either choose to add a pusher or tag axle. Now, in cases where the front axle is the limiting factor, like we have here, we would get the most benefit by adding a pusher axle. And the reason for that is that axle would take some of the weight off the front axle. In cases where the rear axle is the limiting factor, we could add either a pusher or a tag axle. So for our example, we will add a pusher because we also have sufficient space on the chassis for that. And as I do that, just keep an eye on our current payload, which is 23,000 pounds for our 6x4 baseline vehicle, and our overall carrying capacity is 51,500 pounds. So we will refer back to that again later. I'll add the pusher now. Notice how our overall carrying capacity increases by 4,500 pounds, and our payload increases by roughly 6,000 pounds. Our limiting factor is now the triaxle group at the rear, which is limited to 42,000 pounds, and we are almost at 100% for the overall bridge carrying capacity. For a detailed breakdown on these new bridge limits, we can go to the bridge view, where all the most important bridge groups are shown with the distances between the axles and the permissible bridge limits. So for our outer bridge group, axle 1 to axle 4, we have a distance of 21 feet, which is limiting us to 56,000 pounds. To return to our summary view, we can go back to weights and dimensions and summary. Okay, for now we've accepted the default values for our pusher axle that we added. I'll spend a little bit more time on some of the changes that you can make here. For starters, you can change the position of the axle from the driven axle. The default is 49 inches, but you can change that here. You can select the pusher axle to open the menu with all the input values that you can specify for a pusher axle. For starters, you could change the weight of the axle, which is defaulted to 1,350 pounds. The gross axle weight rating is 13,000 pounds, and the bridge limit is 11,600. And this bridge limit is the limit here is due to the tire restriction. So it's the tire restriction of 500 pounds per inch of tire width, which is the minimum that any state can impose on the interstate highway system. Okay, you can obviously change the tires, but we'll come back to that in a minute. All right, our permissible on that axle is therefore also 11,600 pounds. And slightly further down, we probably have the most important input value, and that is the percentage of gross axle weight that is carried by the pusher axle. So you can use this percentage to increase the actual weight that is carried by the pusher axle. If we have a look at the weights table, you'll see that our actual weight at the moment is just over 10,000 pounds. So we are still nowhere near the limit of 11,600. But if you want to, you can increase this percentage to carry more weight on the pusher axle. So that default value of 24.5% is determined by the ratio between the gross axle weight ratings of the pusher and the driven axles. Okay, so just keep an eye on the front axle and the rear axle when I increase the weight slightly on the pusher axle. So we will expect the front axle to be, weight to be slightly reduced, and the same for the driven axles when we put more downforce on that pusher axle. So I'll just increase that by 1%. And if you watch the numbers here, you'll notice that the front axle is now slightly lighter, and so is the driven axle. But you will need to experiment with the weight on the pusher axle to get this to an optimum for your application. So it takes a little bit of trial and error to get this right. And you can just increase the percentages up or down until you optimize the distribution over all your axles. In practice, you would control this through the air pressure in the suspension for this axle. I will go back to the default value of 24.5% for now. Jens, is there a question?
Hi, Martin. Yeah, a question has come, well, quite a few questions have come in, but one of them I think would be easier if you explained it and maybe demonstrated it. It's when you extend or reduce the chassis. Someone has pointed out that the front and rear chassis weights aren't changed or aren't changing, whereas the fuel and crew, the distribution of the fuel and crew are changing. So maybe if you can just explain how TruckScience deals with that, and where the front and rear chassis weights can be updated once the extension or reduction has been done.
Yeah. Thank you, Jens, and thank you for that question. So we will definitely do that. We will be extending the wheelbase of this vehicle, and it is something that we need to remember at that point, is to change the chassis weight front and rear either manually or by selecting a chassis that already has a suitable wheelbase and is pre-populated with correct chassis weights. But I will demonstrate that a little bit later on. Okay, so now we've had a look at all the values that we can change for the axle here. We can also go to the axle tab and raise and lower this axle. So in the raise position, we could carry only 20,000 pounds. If we lower that again, we will carry almost 30,000 pounds. Of course, we can change the tires, but in this case, it's not even necessary to put in wider tires because we are not fully utilizing the gross axle weight rating of this axle. Okay, if we have another look at our dashboard here, we'll see that our utilization of the gross vehicle weight rating has now increased from about 70% to 80%, but we are still nowhere near 100%, which indicates that we can still increase our carrying capacity by adding, say, a second pusher axle. So we'll look at that now. The first consideration will be, do we have enough available chassis space here? Now, it may look as though we do, but in practice, that'll depend on the layout of the fuel tank, the def tank, batteries, and the exhaust, which may occupy this space. To demonstrate that, I will go to Equipment and add a fuel tank. I'll just add a 75-gallon tank and position that under the steps here, just to demonstrate that we don't have enough space here and that we'll need to extend the wheelbase to add another pusher axle. Now, there are two ways in which we can increase that wheelbase. The first will be to go to the toolbar and use that swap vehicle feature. And if we find a suitable chassis with a longer wheelbase, that chassis could already have appropriate or matching chassis weights for the front and rear axles. So we wouldn't need to do a manual adjustment. In the case where we change the wheelbase manually, we would need to make that change ourselves. So we will do the manual change and I'll demonstrate all that. But what I'll also do is, whilst we're making this change, I want to show you the effect that this will have on the turning radius. So let's just go to the turning radius view on the right here, and I'll select the smallest turning radius. And to make that wheelbase change, I will open the vehicle menu and override the wheelbase. Keep an eye on the curb-to-curb turning radius here. That'll increase as I increase the wheelbase. And you can also just look out for the increase to the overall bridge carrying capacity. So I'll just use the tickers here to increase our wheelbase, and you can have a look at the change to the numbers. I'll increase that by 3 feet all the way up to 260 inches. You would have noticed that the turning radius has now increased by about 4 feet, and our overall carrying capacity has increased by 2,000 pounds. By default, you'll notice that the pusher axle is a steering axle. You can toggle this to a non-steering axle as well, and have a look at the effect that that'll have on the turning radius for one. But of course, this will add a considerable amount of tire scrub, which is why some regulations make it mandatory for the pusher axle to be a steering axle. So we'll keep this a steering axle. To go back to our side view, I'll select orientation on the right and go back to our side view. Jens, yes.
I'm on, yeah, good timing there, changing to the side view. There's a question here. When you went to the bridge view, it populated the front axle with a 20,000 pound rating and reported a different percentage utilization than the main screen with the actual 14,600 pound rating.
Okay, I'll just explain that. So looking at the bridge, so the bridge limit on the front axle is 20,000 pounds. So under the federal regulations, the front axle is not affected by the tire width. The gross on the front is only 14,600 at the moment. That is the actual weight. So our utilization of the bridge limit is only 73%. And you're right, the person asking the question is correct. So the utilization is 73%, where we had a utilization of 100%. And that was because the permissible limit is the lesser of the bridge limit and the manufacturer rating of 14,600. So we always have to consider the manufacturer rating as well on that weights table. Whereas here we are only considering the bridge limits. Jens, is there another question relating to that?
No, that's all good. Thank you.
Okay, so this brings me to the question that Jens, that somebody asked early on, and that is, how do we adjust the chassis weight for the extension to the wheelbase? So the manual way of doing this now will be to just select the front axle, go to the original chassis weight, and I'll just override that and increase it by 100 pounds. And I'll do the same on the rear axle. I'll override the original chassis weight and add another 100 pounds here. Your chassis supplier can most probably give you more accurate values for the changes to the wheelbase. So at this point, this is a little bit of an estimate, but roughly 200 pounds, 200 to 300 pounds for the extra 3 feet of chassis length should be sufficient. And it is something that I checked with the manufacturer in this case too. They gave me a value of about 200 pounds for the extension. Okay, so this body is now not suitable for this chassis. So I'll just remove that and swap it out with a slightly longer body. So I'll add a 19.5 foot body and just move that back slightly and then position the hoist appropriately. Okay, so we are now ready to add our second pusher axle. We've got enough space for it. So we'll go back to the vehicle menu, weights and axles, and add our second pusher. Again, just keep an eye on the overall carrying capacity, which is 58,000 pounds at the moment. So when I add that pusher, that'll increase by 5,000 pounds to 63,000 pounds, and our payload is now 36,000 pounds. Okay, so if we look at our dashboard, we'll see that the overall utilization of our gross vehicle weight rating is now 93%. So we're pretty close to the 100% for that. And this is as far as we'll go in terms of modifying our dump truck. If we compare this to the original 6x4 version we had, we'll see that our overall carrying capacity has now increased by 11,500 pounds, and our payload has increased by 13,000 pounds. This shows just how beneficial it is to add lift axles to a vehicle. Jens, are there any more questions before we look at the federal laws? Sorry, we'll look at the state laws next.
No, all good.
Okay. All right, so up until now, we've validated this calculation against the federal regulations. What we'll do now is I'll go and change this to see how this vehicle will perform on Idaho state roads. So I'll go to settings here, to our dashboard, where I can remove the federal regulations and search for Idaho. And we'll start off with Idaho state roads, and I'll come back to the Idaho interstate roads in a minute. But for now, we'll just pick the state roads and apply that change. So you'll notice that the overall bridge carrying capacity has increased by about 5,000 pounds. And that is because Idaho applies its own bridge formula on state roads, which is considerably higher than what is allowed on the interstate highway system. Our payload has now increased by 5,000 pounds as well to almost 41,000 pounds. If we look at the axles, you'll notice that Idaho also allows slightly higher weights on the tandems. It's 37,800 instead of the normal 34,000. And the pusher axles can go all the way up to 13,000 pounds, because Idaho allows 600 pounds per inch of tire width. All right, we've now utilized 100% of our gross vehicle weight rating as well. Let's assume that this vehicle will also need to travel on the interstate. What we can do then is validate against both state road and interstate regulations. What I'll do before I add the interstate regulations is I'll just lock down or override this payload to lock it down so that the software does not recalculate it when I add a second regulation. So let's go back to settings and choose Idaho again, but this time we will add the interstate regulations. And I'll apply that change. You'll notice that we will be all good and legal on state roads, but overloaded on the interstate, hence the red cross. And we apply the lowest weight limits to the weights table here, which takes us back to 63,000 pounds for the overall carrying capacity. For this vehicle to be legal on both state and interstate roads, we could deselect this override to allow the software to calculate the maximum permissible payload again, which will be 36,000 pounds. And we'll get green ticks for both. Okay, so that is this example. You can do a similar study on a vehicle that crosses state lines on state roads only. You can validate your calculation against up to 5 different regulations. Okay, for our last example, we will look at the Canadian regulations. So let's go back to settings and remove these US regulations. We've recently added the Western and Atlantic provinces for Canada. So you can now add a regulation for any province in Canada. I will choose the Ontario SPIF regulations. And I'll also change the measurement system to metric, since these limits are specified in millimeters and kilograms. I'll apply that change. Okay, so the regulations for Canada differ somewhat from the US ones, in that they typically cater for designated truck and combination types. And to assist you with this process, or to guide you towards a compliant vehicle, we've added tips that are shown in the bottom left corner here. So the first tip will let us know that Ontario only caters for one pusher axle. So we can remove the second pusher axle. The next tip provides the details in terms of which schedule this vehicle will be validated against. So currently this vehicle will be validated against Schedule 21, and there's an explanation of a change that we can make to the gross axle weight rating of the pusher axle if we want to validate this calculation against Schedule 23, which would give us higher weights and a higher carrying capacity. To keep it simple, I will not change the gross axle weight rating of the pusher and validate this calculation under Schedule 21. Yes, Jens?
Hi, Martin. A question has come through here that I'm not really able to answer. It's around, I suspect it's about Canadian regulations. And the question is whether switching between steerable and straight lift axles or steerable lift axles, whether we accommodate the difference in allowable kilograms per meter, per millimeter of the tire width. Now, I'm not sure whether you're able to answer that question either, but what I've suggested is that we'll get one of our engineers to get back to this person. But just on the off chance that you do know the answer to it, maybe you can share it.
Yeah. Okay. I think there are probably two, maybe even three parts to that calculation, to that question. I will get to that right at the end, where we look at this the steering element of that pusher axle. I suppose we're nearly done with the calculation, so I'll get to that in a minute.
Perfect.
All right.
Okay.
So we're now validating this calculation under Schedule 21. We still have a red cross here next to the regulations. If we draw down on that, you'll see that that relates to dimensions. For more information on a failure on the regulation, you can also go to the notes and warnings on the right, and go to warnings, where you'll see an explanation that this axle needs to be at least 2,300 millimeters from the driven axle. So that may be one of the question. A part of that question was the distance or the axle spacing. Canada has very strict axle spacing requirements, and that pusher axle needs to be at least 2,300 millimeters from the driven axle. You'll also see that that dimension is highlighted in red to indicate that. So I can just override that and change it to 2,300 millimeters. So that is maybe answering one part of that question, but there are also areas where we measure the interaxle spacing, and if the distance is less than a certain distance, it will reduce the carrying capacity of, say, the driven axles. So that is taken into account, and it would be interesting to hear from the person who asked that question if there's a particular example where maybe you couldn't see this. Maybe we can take that offline, and we'd be more than happy to work through your calculation with you. Okay, so now one last change we could make to this calculation is to adjust with our payload center of gravity. You'll notice that the front axle is the limiting factor, and that we have some unused capacity at the rear. So let's say we could load this vehicle heavy towards the rear, then we can move that center of gravity to the rear until the permissible total becomes the limiting factor. and we end up with a payload of about 19,000 pounds, which is about 19,000 kilograms, which is about 41,000 pounds. So this vehicle will carry the same payload as our quad axle truck on the Idaho state roads. Okay, so that takes us to the end of the live demo, but I will still answer that question about the steerable pusher axle. For that, I'll just switch to the smallest turning radius again and go to the axle. So this pusher axle, if it is not a steering axle, we will get a warning or note or tip again in the bottom left corner to say that there's a requirement for this axle to be a steering axle in Ontario. So it must be steerable. So the calculations cannot be done until it is steerable. So hopefully that'll answer that other question. All right. I'll go back to the side view. Jens, are there any other questions before we go back to the slides to wrap up the session?
No, I think we're all good.
Okay, so let me go back to the slides. Okay, so to sum up, here are a few things to consider when adding pusher and tag axles. To start with, the manufacturer's gross vehicle weight rating must be adequate for the additional weight. You can talk to your local chassis supplier to confirm the gross vehicle weight rating and that the vehicle is suitable for adding more axles. Next, you'll have to choose between pusher and tag axles. For this, you will need to consider how each will affect the weight distribution. The final position of the axles will also be affected by the wheelbase and available chassis space. If you have to increase the wheelbase to accommodate the additional axles, you will need to determine the effect this will have on the turning radius and decide whether or not the axles need to be steering. You'll also need to consider the required gross axle weight rating and tire size for your additional axles. Your choice will be driven by the application and regulations under which the vehicle will operate. To get the optimum balance of weight over all the axles, you should test a few scenarios to work out how much weight each pusher or tag axle needs to carry and how to set up the air pressure in the suspension to achieve the required weight. Lastly, but very importantly, you need to understand how the overall carrying capacity is affected by the federal, state, or provincial regulations for the area in which the vehicle will operate. You'll remember that there was a difference of about 5,000 pounds between the federal regulations and Idaho state laws for our quad axle dump truck. I've used our axle weight calculator to work through these examples today. If you would like to try the app yourself, please visit TruckScience.com to register for a fully functional free trial. You'll be up and running in under 5 minutes. Jens, are there any more questions?
Martin, there's another question that's come through there. Is the turning radius affected when equipping the steerable lift axle with wide base single tires versus duals?
Wide base single tires versus duals. I think that might be a good one to take offline with the person who asked that question, just to double check exactly how we deal with that scenario, because it definitely will depend on whether it's also steerable or not steering.
Yeah. Okay, I'll arrange that then offline.
Yeah. Okay, so I will end this webinar shortly. But before you go, please rate the webinar and leave any comments or questions you'd like to share with us. If you'd like to set up a personalized demo of the app, just leave your contact details in the comments and we will gladly set that up. Thank you for joining us today. We look forward to your feedback. Goodbye.